In this video, we're going to find a way of algebraically finding the vertex of any parabola. In part A, we want to find the horizontal intercepts of the graph of y equals x squared minus 2x minus 3 using the quadratic formula. As a starting point, we'll need to remember that to find the horizontal intercepts, which are the same thing as the x-intercepts, we will need to set the y value equal to 0. So taking our equation, y equals x squared minus 2x minus 3, and setting the y value equal to 0, would give us the equation we need to solve, x squared minus 2x minus 3 equals 0. To solve this using the quadratic formula, we need to make sure the equation is in standard form and set equal to 0, which it is. We need to identify our a, b, and c values. So our a value is 1, our b value is negative 2, and our c value is negative 3, and we'll substitute those into the quadratic formula. So our x values will equal the opposite of negative 2 plus or minus the square root of quantity negative 2 squared minus 4 times 1 times negative 3 all over 2 times 1. As a first step of simplifying, the opposite of negative 2 can be cleaned up to be 2. Underneath the radical, negative 2 quantity squared is a positive 4. Negative 4 times 1 times negative 3 is a positive 12. And 2 times 1 in the denominator is 2. Continuing to simplify this further, 4 plus 12 under the radical will become 16. And so we will have x equals 2 plus or minus the square root of 16 over 2. We can go one step further while keeping it in this condensed form. The square root of 16 is 4. So we now have x equals 2 plus or minus 4 over 2. At this point, we will need to separate it into the two possibilities. One possibility is that x is equal to 2 plus 4 divided by 2. The other possibility is that x equals 2 minus 4, all divided by 2. In the first case, where we have x equals 2 plus 4 over 2, 2 plus 4 is 6, and 6 divided by 2 is 3. In the case where x equals 2 minus 4, all divided by 2, 2 minus 4 is negative 2, and negative 2 divided by 2 is negative 1. So we will have x-intercepts of 3, 0, and negative 1, 0. In part B, we can look at the graph of y equals x squared minus 2x minus 3 to the right and recognize what the vertex is. The vertex in this particular case is the lowest point on the graph, and the coordinates of the vertex are 1, negative 4. While it's not explicitly asked for, we can verify our work from part A was correct. We calculated that the x-intercepts should be negative 1, 0 and 3, 0, which matches the graph that we've been given. The fact is, there is a direct relationship between the x-intercepts and the x-coordinate of the vertex. This is partly based on the fact that a parabola is symmetrical. If we consider the axis of symmetry, the vertical line that goes through the vertex, we should notice that the x-intercepts are the same distance away from the axis of symmetry on the x-axis. They are both 2 units, either to the left or the right, of the axis of symmetry. In part C, we want to compare the x-coordinate of the vertex to the work we had in part A, when we were finding the x-intercepts using the quadratic formula. We know from the graph that the x-coordinate of the vertex is 1. If we look back to the quadratic formula and all the work that we did, the fact is that this x-coordinate of 1 was subtly hidden inside of the quadratic formula. If you ignore the plus or minus component of our work, and just consider the opposite of b over the 2a, right there is the x-coordinate of the vertex. This isn't just a coincidence. Again, going back to the symmetry, the x-intercepts are going to be equal distance to the left and right of the axis of symmetry, and the axis of symmetry is based on the x-coordinate of the vertex. The plus or minus square root of 16, which became a plus or minus 4, keeping in mind this is plus or minus 4 all over 2, gives us our 2 units to the left or the right. But if we don't need to find the x-intercepts, and all we need to do is find the x-coordinate of the vertex, all we need to do is consider everything except for the plus or minus radical component. So taking this to a more generalized situation, in part D, given the general solution to a quadratic equation is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, What is the generalized formula for the x-coordinate of the vertex? The generalized formula is everything from the quadratic formula minus the plus or minus radical component. So I can always find the x-coordinate of the vertex using the formula x equals the opposite of b over 2a. That essentially gives us the center of the graph. Now this formula, x equals the opposite of b over 2a, only gives us the x value, or the x-coordinate of the vertex. So if we know the x-coordinate of the vertex, how would we find the y value of the vertex? Well, we'd do it the same way we would do anything else. We'll simply take that x value and substitute it into the quadratic equation we're working with. We'll plug that x value in and calculate the y value.